Good evening. I'm Dan Sheely, and I'm the director of the Collegium Institute for Catholic Thought and Culture, as well as the executive director of the University of Pennsylvania's Program for Research on Religion and Urban Civil Society, what we call PRUX. On behalf of both this PRUX program and the Collegium Institute, it's my pleasure to welcome you to our evening event, Manufacturing Minds, the Fall 2020 Forum of the Magi Project. The Collegium Institute's Magi Project delivers courses, lectures, seminars, and other outreach activities that explore the distinct but complementary approaches of science, philosophy, and theology to fundamental questions of the universe and of our own place within it. Our most recent forum featured Professor Karin Oberg of Harvard speaking on exoplanets, extraterrestrials, and the wonders of creation. I'll preview our next event just before we conclude tonight's program. Before we begin this program, however, please allow me to thank our generous sponsor, the John Templeton Foundation, as well as our co-sponsors, including the University of Pennsylvania Department of Neuroscience, Penn's program in the Biological Basis of Behavior, BBB, the Cornell University chapter of the Society of Catholic Scientists, and the Zephyr Institute at Stanford. I'll now turn things over to tonight's moderator, my colleague, Dr. Janice Chi, the interim director of the Magi Project, in order to introduce the subject of our conversation, as well as our distinguished speakers. Welcome, Janice.
Thank you very much. I want to follow Dan in thanking everyone here for joining us today for our special event with Professor William Hurlbut and Professor William Newsome. It is my special privilege to introduce our two eminent speakers who are both professors at Stanford University. Professor William Hurlbut, MD, is adjunct professor and senior research scholar in neurobiology at Stanford Medical School. After receiving his undergraduate and medical training at Stanford, he completed postdoctoral studies in theology and medical ethics at Stanford and with the Reverend Louis Bouet of the Institut Catholique de Paris. He is a leading thinker on the ethical issues associated with advancing biomedical technology, the biological basis of moral awareness, and studies in the integration of theology with the philosophy of biology. His numerous publications include Altruism and Altruistic Love, Science, Philosophy, and Religion in Dialogue, published in 2002 by Oxford, and Science, Religion, and the Human Spirit in the Oxford Handbook of Religion and Science. In addition to faculty responsibilities at Stanford, Professor Hurlbut has also worked with NASA on projects in astrobiology and was a member of the Chemical and Biological Warfare Working Group at the Center for International Security and Cooperation. From 2002 to 2009, he served on the President's Council for Bioethics, from which his work on embryonic stem cell research is well known, and he remains a steering committee member of the Templeton Religion Trust. Our other eminent speaker, Professor William Newsome, is the Harmon Family Professor of Neurobiology and director of the Wu Tsai Neurosciences Institute at Stanford University. He is a leading investigator in systems and cognitive neuroscience and has made fundamental contributions to our understanding of the neuromechanisms underlying visual perception and simple forms of decision-making. Among his many honors are the Distinguished Scientific Contribution Award of the American Psychological Association, the Dan David Prize of Tel Aviv University, the Carl Spencer Lashley Award of the American Philosophical Society, and the Championnement Vision Award. His distinguished lectureships include the 13th Annual Marr Lecture at the University of Cambridge, the 9th Annual Brenda Milner Lecture at McGill University, and the Distinguished Visiting Scholar Lectures at UCSD's Kavli Institute of Brain and Mind. He was elected to membership in the National Academy of Sciences in 2000 and to the American Philosophical Society in 2011. Professor Newsome co-chaired the NIH Brain Working Group, charged with forming a national plan for the coming decade of neuroscience research in the United States. Both Professor Hurlbut and Newsome are also directors of the Boundaries of Humanity project at Stanford, which is a major initiative investigating humans, animals, and machines in the age of biotechnology. In their words, the activities of the Boundaries of Humanity project are organized around several important questions central to human self-understanding. For instance, what are the unique and defining features of human nature? What biological composition, social conditions, and spiritual concepts support the fullest flourishing of these distinguishing dimensions of human life? And most perplexing, what role will our emerging technologies and the cultural ideas that guide them play in shaping the human future? As a philosopher, these questions stand out to me as some of the most perennially important of all questions. And our speakers have written concerning their project that they seek, quote, an understanding of the boundaries of humanity that defends human dignity and promotes the personal, social, and spiritual flourishing of human life. And I think this aim seems likewise integral to our topic for this evening's conversation on the nature of human consciousness and its implications for our understanding of human nature and life. These were the main questions, in fact, asked by a special course that was co-taught last year at Penn by Professor and paleontologist Peter Dodson and myself earlier this year, titled What is Life? And as a little background to the evening, this evening's event, this course was in fact a major impetus for the organization of tonight's event. I might also mention that the title of our course, in the form of a question, What is Life?, proved to be a minor source of consternation for some of our students at Penn, who felt that they must have a very clear and distinct answer to it. So I have been also hoping that our eminent speakers tonight might also be willing to resolve that issue for Professor Dodson and myself. I might also mention that Professors Hurlbut and Newsome have been close friends for over 2 decades, and this is evident in their case that such intellectual friendship, as Aristotle once said, usually inspires collaborative projects of significant benefit to the rest of society at large. So we are especially privileged in this light to be permitted to eavesdrop on one of these conversations between authentic friends in pursuit of a higher good. Having said this, there will, however, be time for a Q&A from the rest of us. So I will do my best in the last third of this third part of this event to take your questions. Please forgive me too if I don't get to your question, but please feel very free to write your question in the Q&A bar, which is located at the bottom of your Zoom screen. So with that, let me turn to our presenters with an initial set of questions. The prospect of manufacturing minds is linked, of course, to developments in artificial intelligence, which are rapidly accelerating this decade, so much so that we are now countenancing artificial intelligence programs that can improve on their own, according to scientists, generation after generation without any human input. And such programs have been heralded as introducing what seems to be, to many people, a kind of evolutionary principle and what seems to be a kind of internal volition to otherwise inanimate things, such that we might now describe such things as being alive. So the first set of questions that arises from these considerations is whether these are indeed representing new forms of life, and do such programs indeed learn according to their proponents. I might add that at the same time, research is also accelerating to develop neurons from stem cells to grow what scientists are calling organoids, and what we lay people through media sensationalism are calling mini brains, and right, the idea of growing a brain in a dish. And so some people have seen in the prospect of mini brains a form of development that parallels artificial intelligent technology, in the sense that this is also a way to manufacture minds. And so likewise, we may ask the question, is this too a form of life that is similar to the form of life that we are familiar with? And from your medical and neurobiological perspectives, how should we understand these advances? And in particular, what can science tell us? And what does science not tell us about human nature and life?
Small questions. Bill, you want to go first or you want me to?
I think maybe you better.
Okay. Okay. So Janice asked two really big questions, one about artificial intelligence and one about brain organoids, and should they be regarded as new forms of life? And I would say in both cases, no, at least not yet. But I think in both cases, it's not crazy to think hard about that problem and think hard about what standards you would have for saying something that is alive. I'll just put those out there as my kind of opening statement. Bill, why don't you chime in and then we can talk in a little more depth about that if we want to.
Well, I would say the first thing we have to do is parse out that question a little more and say, what do we mean by alive? Although we, in a certain sense in science, say that we believe a cell culture has living cells in it, we don't mean quite what we generally mean when we say something is alive, because when we think of something being alive, we generally think of it being a living organism. An organism is quite different from a biological entity that is artificially sustained in a culture dish. So that then raises the question of what constitutes an organism in the first place. And that's where we start to get into the difficult question of partial expressions of human nature, simulations or simulacrums of what we are. Of course, we're speaking here of contrasting living creatures of other sorts and non-living entities like machines, in contrast to human beings as living creatures. So the question then becomes, how would we differ in nature? So let's start by looking at machines. Bill, got any thoughts about that? Do you think we could ever create a machine that could either simulate or actually engage in the existential qualities of a human being?
I think it's possible. Typically if you ask a biologist what is life, you'll get a complicated answer about heritability through nucleic acid molecules. You'll talk about cells surrounded by plasma membranes and metabolic processes going on inside the cell. But the people who are really pushing the envelope on artificial intelligence really argue for a more expansive version of definition of life. And the simplest one that I've read, I've got it sitting right in front of me right now. It's by Loicky and Pollack at Columbia. They say, we propose a simple but challenging definition of life as the property of an organism that possesses any genetic code that allows for reproduction, natural selection, and individual mortality. So those are the three components that would allow a Darwinian style evolution to take place. And it has the very deliberate advance that anything made with synthetic DNA or synthetic molecules here could qualify as a definition of life under those circumstances. And I don't think that's crazy for another reason that Bill, you and I have discussed before. I asked people to do a thought experiment with me and imagine, each of us has about 100 billion neurons, nerve cells in our brains, more or less. And I like to do the thought experiment of saying, well, what if we could take one of those natural neurons out of there and replace it with an artificial one that mimics all the functions of the natural neuron? So it gets all of the synaptic inputs that the natural neuron gets. It has all the synaptic outputs to the other real neurons. But you've got this one little tiny bit of silicon or whatever our magic substance is. Would I still be me if I replaced one neuron that way? And I think, the answer is clearly yes. I mean, the signals will be flowing into that neuron, the fate neuron that normally do, and they'd be flowing out of it. And I don't think it would have any effect on the functioning of the whole as long as it reproduced all those functions. And then you just do that experiment 100 billion more times, right? And now you've got a completely artificial brain inside my body that somehow magically at this point interfaced to the rest of the body. But would it be conscious? Would it be aware? Would it have all my memories? I think absolutely yes. I don't think there's anything, it's something very precious about carbon, hydrogen, oxygen, and nitrogen that allow this life on Earth to exist. But I don't think there's anything magical about them. And I think to the extent that there's something, that the deepest cleverness here is in the organization, the way the parts are organized together. So I think it's possible to have completely artificial entities that reproduce something like animal or human awareness. I don't think we're anywhere close to it yet, but I don't think it's impossible.
Well, that first of all, raises a very fundamental question about whether there is some other material substrate that could substitute for the biological basis of mental operations in the human mind or any other kind of mind. And there, I think we have to look very carefully at what the probability of that is, just from what we know of how brains operate, how embodied brains operate. So just speaking of the brain itself and the neurons themselves, they strike me, first off, as being something vastly more complicated than anything that can be digitally simulated right now. And maybe, I mean, I know there are digital simulations, analog processes, but many operations in the neurons are analog. They're in the sense that they aren't chunked in little units. They are gradual and cumulative. And when you think about the fact that any single cell in the human body probably has maybe 10 million different biochemical components, and neurons, I guess, are equally complex, but not only that, they interact in a very complex way, not just with other neurons, but with the glial cells, which are 10 times as numerous in the brain. And so you start to get a very, very complicated thing to simulate. So I'll pause for a moment in that. I got more to say, but what do you say to that, Bill?
Well, I'm not going to argue. I'm not going to sit here and argue that the brain is not complicated and that neurons are not complicated. They obviously are. And we keep learning more about neurons and interesting properties they have every year. So I completely take your point. They're very, very complicated. They have lots and lots of properties that are difficult to capture in simulation right now, in part because we don't even know some of the properties right now. But I don't think any of it's magic. I think it all works according to certain principles. In fact, you know, when you want to build a model of a neuron, one of the things that's toughest is actually knowing which of the details you have to get right in order to capture the functionality of the real neuron, and which ones you can just glide over because there's certain details that really aren't important to the functioning. It's trying to get to those operative principles. And so a lot of building neurons artificially and simulating is deciding what to include and what not to. You know, you remember Francis Crick's famous quote that, you know, what was the key to discovering the double helical structure of DNA? And he said something, I can't quote it exactly, but he said it was understanding that it's okay to ignore some of the data. You know which ones to ignore. So I'm totally on your side that neurons are very complicated, but I don't think that imposes any impediment in principle to having well-functioning artificial neurons.
Well, let's talk about what data we're going to ignore here for a moment. I agree that's very interesting, and but well, so let's back up a second. You're basically saying that the human mind is a technology, and here's a quote from a guy named Alan Newell. He says, "Our minds are a technology like other technologies in being a set of mechanisms for the routine solution of a class of problems." Okay, a technology. And surely we all acknowledge that it certainly appears as though the mind is mediated by matter. And in a certain rough analogy, it is a technology. On the other hand, there's something not quite right here. Something seems smuggled in without our barely noticing it. The mind is an embodied mind, mysteriously issuing forth from within a living organism, inseparably body and mind. We are psychophysical unity. That's the way we experience ourselves, right, Bill? And sometimes we feel like we're free-floating thought, but then maybe a pinprick or a bee sting or something pulls us back to the awareness of our physical frame. And though, since it's a mystery, that intuition could be wrong. It could be that it's not mediated by matter, but it seems to be. And therefore, it arises within minuscule molecular motions that we call mechanism, and therefore it's a technology of sorts. But if the mind is materially mediated, even if it is, it's more than a mechanism, since it apprehends, unlike any kind of mechanism we know of, it apprehends, it draws into awareness concepts and ideas, immaterial realities that are as real or more real than matter. And who knows what matter is anyway, by the way. So that is, the mind is internally operated, not just externally ordered like human created machines. There's a self in there, qualities of consciousness, including subjectivity and sense of freedom, that are very unlike mechanism. What do you think about that much?
You have more? Yes, I completely agree that our minds are embodied. Probably I'm even more radical on that than you are, because I do believe that our minds, everything in our mental, emotional lives are mediated via matter. It's sort of a fundamental, it's a central, I call that, in some sense, I call it a central dogma of neurobiology. And obviously that's an allusion to the central dogma of molecular biology, which is DNA to RNA to protein, right? But the central dogma of neurobiology would be that all of our mental lives, emotional lives, conscious lives, purpose, goals, aspirations are somehow rooted inextricably into the biology of the brain. And, that's not a proven fact. That's just an assumption we make as we go about our work every day. Because if it's not, it's going to be really hard to measure. And if it's hard to measure, it's going to be hard to do science. So when we go in the lab and we be scientists, we operate with that dogma in mind. But, the more we learn and the more we can actually track higher functions of the brain down to specific nuclei and specific tracks, and with the power of new tools that we have to turn brain circuits on and off artificially, and we can see how bringing brain circuits online and offline instantaneously changes sophisticated behaviors instantaneously. I mean, when you do these kinds of experiments and you steep yourself in reading these kinds of papers and the remarkable things that are going on, it really has a way of convicting you of, that everything about that mind really is tied to the biology. Now notice I'm choosing my words carefully here. I'm saying it's inextricably linked to the biology of the brain. I'm not saying that it is determined in any deterministic sense by the biology of the brain, but I think the brain is very special, and I agree with you about all the special characteristics of our brain, and it's hard to conceive of something as with this rich internal experience that we have of a consciously experienced world and a valuing world. It's hard to see that in any mechanical artifices that we have right now. But, over the next century of development of artificial intelligence, will we see that? We might see that. But I agree with you that right now there's nothing that compares.
May I ask a question about consciousness and the ways in which we might distinguish between consciousness and self-consciousness? So on this score, it seems, Descartes' cogito ergo sum argument actually seems attractive for our purposes, right? Where Descartes says there's a kind of reflexive consciousness in which one is able to say, I am thinking that I am thinking. And I suppose I would want to know, Professor Newsome, whether you think that an intelligent, right, a kind of artificially intelligent machine could ever have, right, sort of exhibit this kind of reflexive consciousness, right, and saying, I am thinking that I am thinking, and actually mean it, right? And I know a lot of your work has dealt with decision-making, and right, are there features of human decision-making that are unique in this respect? Maybe that sort of touch on what Professor Hurlbut was saying about subjectivity, right? And did Professor Hurlbut just leave us here? Right. So anyway, it's good. This is a question for Professor Newsome. Hi, Professor Hurlbut.
He's back. You okay?
Yeah, I'm back.
All right.
Right. So I mean, this was one of sort of the big questions at Penn that we were examining with our students, right? Whether a machine actually could exhibit a kind of self-consciousness that's reflexive in a kind of Cartesian way, rather than just, let's expand the idea of consciousness so that we can include machines in them?
Yeah. Yeah, so there's a whole lot of issues bound up in that question, as you are probably more aware than I am because of your philosophy background. But I think before I say anything about consciousness, I want to just say how much confusion that word creates, because we use it in so many different ways. And just, for people, I mean, there are at least 4 ways right off the bat, right? We can talk about somebody being conscious versus unconscious in terms of pathology, a pathological state. They get hit on the head and they're unconscious. We talk about people being conscious versus unconscious in terms of sleep versus awake, right? They're unconscious when they're asleep and they're conscious when they wake. We talk, this is probably the more common one, about, Crick and Christoph Koch talk a lot about subjective awareness, and they kind of equate awareness with consciousness. And this would be a kind of phenomenal consciousness that we have of our world and being in the world. And probably most animals have that kind of consciousness in addition to humans. But then there's a 4th level that you mentioned, Janice, about self-consciousness and the ability to reflect on oneself. In the simplest psychological terms, this is what psychologists would call metacognition, thinking about your own thinking processes. And there's actually some nice behavioral evidence. I'll give you examples if we have enough time of some simple metacognitive abilities being present in monkeys and even in mice, if you believe the data. But there are these sophisticated levels in humans that seem unique to me. And I don't know how much you want to hear about that. I mean, I have this little 5-year-old girl, daughter, who lives with me. And on her 3rd birthday, she was developing an origin story for herself and developing a future story about what she was going to be when she grew up. This is on her 3rd birthday. And she became aware, that she knew she came out of her mama's tummy, but during some conversation, it became clear that she thought she had come out of mama's tummy through mama's mouth, which is very reasonable conjecture, right? Because it's the biggest orifice, right? And most obvious one. And we had to explain to her about the esophagus and different things like that. But she thought she was in mama's tummy. And she said, and I remember, mommy, that I was hungry and you ate breakfast and milk and cereal came in your mouth and down your esophagus. And I went like this and it was yummy. And she had an origin. She has an origin story. She talks about herself in the womb and she talks about what she wants to be when she grows up. And I'm thinking to myself, listening to this little 3-year-old prattle on about things like this, like, what other species on this planet does these things? And I think the answer is none. Absolutely none. Being able to go back in time, project back in time, forward in time, conceptualize, symbolize, do manipulations on symbols. So I think there's something very special about human brains and human consciousness, but we have to kind of define, what level we want to talk about. But I've already foreshadowed the direct answer to the question by telling you that I think that if you substituted every natural neuron in my brain with an artificial one that performed its functions perfectly the way the natural one did, then that entity would be conscious and it would have its own consciousness. So I do believe that's possible, but I'm with Bill and I think with you, Janice, on the issue of embodiment. I don't believe, I'm deeply skeptical about what a brain, a disembodied brain sitting in a vat would be capable of, if anything. I think, that a lot of our viscera and our endocrine system, things that affect the brain, our gut, the bacteria in our gut exude chemicals that affect our brains. We know that now. And we are not just our brains. We are, as Bill says, a psychophysical whole, a psychophysical unity. And I think an artificial brain still would have to have a body to interact with and develop purposes for behavior, and develop purposes for behavior. So my own hunch is that if we ever have artificially intelligent beings that come close to human style or animal style awareness or consciousness, it's going to come when you marry artificial intelligence technology to robotics. I think it really needs to be embodied, and it needs to be exploring the world. It needs to be trying to solve problems in the world. It needs to be learning. I am quite skeptical that unless without extensive interactions and problem solving, you're going to get anything like human consciousness. You might get some other kind of consciousness, that I can't describe it. I don't think it'd be very much like humans, but I do think it's possible that an artificial entity would have that kind of consciousness.
Well, that's really interesting, Bill, because I remember, Bill will recall that several years ago, we invited Ray Kurzweil to our class. I know Ray Kurzweil because I was in his movie called Transcendent Man. I was the bad guy that says, no, this singularity thing you're picturing in the year 2034 isn't going to happen. You don't understand how complicated biology is. And I'll stand by that. But he's a very interesting guy and quite a nice guy. But he was giving us the same kind of computationally grounded perspective of human nature, that the brain is just a technology and so forth. And Bill himself interrupted him finally and said, hey, what about emotion? You remember that, Bill?
Oh, yeah, I remember it very well.
Yeah, so when you say we're going to have an embodied cognition and some kind of a robotic device can be it, you need to include something more than just motion in that robotic equation. Janice cited Descartes, I think, therefore I am. One of my students said, I feel, therefore I'm real. And I think that gets actually in a way closer to the core, the crux of the matter.
It also has a nice ring to it. It's
yeah,
good.
It does.
I feel, therefore I'm real.
So
like
early in the computer revolution, Stanford psychologist David Rumelhart said, the knowledge is in the connections. And at the time, that was a brilliant insight regarding machine operation, because taken literally, because it showed that you could actually work complex computational engagements and solutions through varying connections, just digital connections. So the knowledge is in the connections, but that can't be true literally, because at least as we know it now, computers, there is no knower in a computer. So therefore there's no real knowledge. And that's the question. Leibniz himself is famous for a statement where he said that, well, I'll read it to you. He says, suppose there were a machine so constructed as to think, feel, and have perceptions. It might be conceived as increased in size while keeping the same proportions, so that one might go into it as into a mill. That being so, we should, on examining its interior, find only parts which work one upon another, and never anything by which to explain a perception. So we talked earlier, Janice brought up the notion of consciousness. It's very interesting because the physicist Russell Stannard has pointed out that when we speak, when people from the Judeo-Christian tradition speak about the ultimate source and significance of existence, in reference to God, of course, they do not describe it using physical terms. Our sense of the very ground of being is drawn from inward experience, and it's expressed in personal terms, such as love, purpose, compassion, goodness, morality, expressions which do not figure in physics equations and so forth. And Stannard goes on to say that the language used in reference to God is fundamentally that of consciousness, the aspect of human life that is at once most subjectively evident and yet most inexplicable within the current conceptual and methodological tools of our empirical science. So we're up against a strange problem, because the mind may be materially mediated, but it is also suffused, as has been pointed out by some people very thoughtful on these matters. The mind is suffused, it's surrounded, and it's strategically deployed in the context of what's been called tacit knowledge, that goes way beyond anything that could be easily put into a physics equation. It's the personal existence down at the bottom of our being from which human consciousness arises, and from which the deepest meaning, that Bill referenced meaning earlier, meaning seems to arrive from those levels. The other, I mean, I agree there's computation going on in the human mind and brain, but just to say one more thing about this, I always begin the class that Bill and I teach on ethical issues in neuroscience. I always begin it by saying, in a kind of ironic way, not make a scientific statement exactly, but I start by telling the students there is no brain. The brain is just a kind of term of convenience, a reification. Of course, there's a brain. You can cut it out and look at it in the autopsy room, but functionally, it's embedded. It's connected with a vast number of inputs from the peripheral nervous system, which themselves dwell in every dimension of the body. It's surrounded by the fluids of the body, which change its hormonal milieu. It isn't one thing. It's not a static thing. It's a responsive entity that is subject to the context, the biochemical context. These neurons you're going to create, they're going to have to be bathed in that same complex milieu of systemic circulation, experienced traversing the world, and so forth.
Hormones.
And most of all, the emotions. So what do you make of the feelings?
Okay, so let me say a couple of things. So I think there is a brain, but I agree with you that it's deeply embodied and deeply interactive with the rest of our bodies, and our bodies are interactive with other bodies around us, right? We are all in this big, in some literal sense, we are all in this together. Nevertheless, I am a central nervous system chauvinist. I'm a brain chauvinist. And my little intuition pump for that is just to have you think about this assertion that a brain transplant is the only possible transplant surgery in which you'd prefer to be the donor rather than the recipient. So just think about that for a minute. So probably if I ever have a heart transplant, I'll be very, very lucky and feel fortunate to be a recipient. Ditto for a kidney or lung or anything else. But if I have a new brain in my body, I'm out of there. Wherever I am, it's not in that body anymore. It went where my brain went, wherever my brain went. So I'm a brain chauvinist. I agree that it's embedded. I agree that we're all embedded with each other. The brain changes constantly in plastic fashions. That's absolutely correct. Now to go back to the feeling thing, and this gets back to the consciousness theme again. Bill, you know this very well, and many of our listeners, I'm sure, know this, and Janice knows very well. But there may be a few of you out there who don't know of a philosopher is Australian, but he's at New York University now, named David Chalmers. And Chalmers talks about the hard problem and the easy problem of consciousness. And the easy problems of consciousness are that we are going to understand things in mechanistic terms, things like attention, like memory, like decision-making, like planning. These are easy with quotes around them because none of them are easy, as you've already pointed out for single neurons. They're all tremendously difficult, but we can, using our present science, we can envision ways of understanding them and explaining them with our present science. But Chalmers says there's another class of problem which has to do with the subjective feeling I think that you're describing. What about feeling, what about that subjective nature of pain? And he says that's a hard thing. Why should matter in the form of neurons elicit that kind of internal reality, that kind of internal subjectivity? And that kind of critique, if you will, of the powers of our modern science to understand consciousness goes back a lot to a very famous essay that I'd recommend to any listeners or participants here who haven't read it, called "What Is It Like to Be a Bat?" By Thomas Nagel. And Nagel's key argument is that there's something subjective that it is like to be anything, to experience the world with sonar and sound waves bouncing off of objects and coming back, and that has to do with the sense of subjective reality, and that it is, Janice, that is the I feel, therefore I'm real kind of subjective reality. And Nagel argues that because our current science is intrinsically third person, that we're trying to make objective measurements that can be replicated anywhere in the world when science is doing its thing right. It can be replicated, it can be transported, it can be used, it can be built on, precisely because it's not subjective, because it's third person and objective. But consciousness, this kind of consciousness that we're concerned about here, is intrinsically first person. It's not objective, it's intrinsically subjective. And Nagel says, how can a third person science ever hope to explain something that intrinsically is first person? Because he argues the more you get away and objectify, the less of the real thing you have left. And I'm an unusual neuroscientist. Most neuroscientists really, really detest this argument. It's almost like a reflex. They get angry, actually. You can always tell when you're talking about somebody's religion because they get angry instantly about it. And this is almost a point of semi-religious dogma for neuroscientists. Many neuroscientists, I'd say in my experience about 90%, that they have a reflexive dislike of the notion that there's anything about the human mind that will not be explained by a triumphant neuroscience, whether it takes 100 years or 500 or 1,000, whatever, that it's all just mechanics and we'll figure it out eventually. And I guess I'm more skeptical than that. I'm more on the Chalmers side. And I'll tell you, when I came to Stanford, my first faculty position was SUNY Stony Brook, and this is not to diss Stony Brook at all. But when I came and I knew I was going to be teaching Stanford medical students as opposed to undergraduates someplace, I was really, because I had to give these systems neuroscience lectures. And, you know, Wilder Penfield is a famous neurosurgeon who did these things showing that you can elicit subjective visual sensations and subjective auditory sensations by electrically stimulating the brains of conscious human patients in the right place. And I was always afraid that somebody would ask me, why is it that when Penfield electrically stimulated visual cortex, you see something, and when you stimulate auditory cortex, you hear something? All you're doing is activating neurons with electricity in both the situations. And why are those subjective experiences so different? And, you know, I've been teaching medical students at Stanford for 32 years now. No one has ever asked me that question. So I was creating problems for myself. But Bill, I think I agree with you on this key point, that there is an internal subjectivity and internal first-personness to us. And it's a point Janice made by citing Descartes. That is the fundamental reality that we start with, and there are lots of mechanisms that mediate that reality, but that reality itself is something that I don't know if it's going to be accounted for in the end by at least our current science. That's just my take. There are probably some neuroscientists out there at Penn listening to this, and they're outraged, and they'll get on the Q&A and tell me why I'm all wrong about this. That'd be great.
I'll make sure to prioritize their questions.
Yep, good.
May I ask a further question about Nagel? So I'm very happy that you brought up this essay, which is a very famous essay, and our class read it at Penn. So, you know, many of the ancients, right? So Aristotle and then his medieval commentator Aquinas followed him in saying that, in arguing that there are parts of human mental activity that actually do not involve the brain at all. And I take it this is one of the claims that would really enrage most neuroscientists too, right? But I wonder what you, Professor Newsome and Professor Hurlbut, think, right, of this philosophical claim that, you know, many Aristotelians, I think, are not quite sure how to integrate this with the science, right? That seems to show, you know, when you talk about embodiment, fine, right? We're not saying that consciousness is reducible, right, to the physical sort of substrates, but necessarily there has to be a substrate, we think. And what Aristotle, right, seems to be saying is, you know, sometimes you don't need a substrate.
Yeah.
So, you know, I mean, is there any evidence of this from, right, the neuroscience that's available to us?
Bill is much more sophisticated, knowledgeable about Aristotle and the Greek and medieval traditions in general. So I'm going to let him take first shot at that, and then I may or may not have anything to add on.
Well, can you phrase that a way that I can get a little better handle on it?
I think it's an assertion from Aristotle and the Greek ancients that there are things that are real that have no physical embodiment.
Right. So let me give Aquinas' very concise summary of Aristotle, which is, he says, understanding requires no corporeal organ, and he means the brain. Right. So there's actually a human activity of understanding that they think don't require, right? Certain features of that activity don't require the brain. And is that too far away from what you're saying about embodiment and Chalmers and this kind of subjective irreducibility that Nagel is suggesting?
Well, I'm not a theologian and I'm not a philosopher. I kind of have some semi-useful knowledge of both. But there are very ancient traditions on idealism and realism. And Plato himself was kind of a realist, idealist, if you will, who believed in the real existence of ideas as conceptual objects, not just creations of the human mind. And I think that anybody who comes from a Judeo-Christian tradition has to believe there is something antecedent to that is the very source and ultimately the significance of the material world, that itself is not a created entity. I mean, God creates ex nihilo. God does not create the world. He's not part of the created world, and he or she, I don't want to get involved in the gender, those are just conventions of thought. God as the source of existence is antecedent to the created order. And in that sense, I think we need to take more seriously the reality of what are sometimes called spiritual realities, namely immaterial realities that transcend their instantiation in matter. So in that sense, I mean, but I'm very much with Bill on the concept that I believe that human embodiment and this world in which we live form a complementary system through which we know deep truths that transcend matter. In that sense, the world itself is a language of being and a language that we can learn very deep things. And, it was very interesting. Bill cited Nagel, and Nagel's whole notion, what is it like to be a bat? Well, we can't know what it's like to be subjectively anything else because we are not something else. But we can try to imagine, and I think maybe human beings can go farther anyway than any other creature in imagining what's like to be something else. Plato had this idea in the Timaeus that other creatures could be known by subtraction, that they were less than humans by subtracting qualities humans have. The interesting thing about human nature as an embodied nature, and here we come back to the robots Bill needs to have full human existence, like human existence. Those robots are going to have an embodied existence that is very similar to the human embodiment, because human embodiment is a very remarkable medium of engagement with the world. We have, I think it's fair to say, the deepest and most articulate communion with the deep nature of the world. In that sense, the human body is the privileged form for apprehending the depths of both comprehending and then controlling the world itself, which, by the way, looked at phylogenetically might explain why we are as we are. Simon Conway Morris has referred to the human being, the human body form specifically as life's solution, that we exhibit the capacity to penetrate deep into the realities of the world. Well, when you start looking at human nature, you get something more than just, flexible hands, what Aristotle called the tool of tools, and functional operation in the world we share with the other hominins, the rotation of the shoulder joint, which gives our arms a lot of flexibility. I mean, mechanically, the body's a marvel, but more specifically, and what's more profound about the human body is our body form that allows intersubjectivity. And that brings us down to what I think is really profoundly significant in this matter of what is it like to be something. What is it like to be a human being? It's a dialogical existence. It's an interactive, intersubjective, interpersonal existence. We develop what we understand of ourselves and others, our autobiographical self and our narrative of existence is grounded in this interrelations with other people. It's been suggested that consciousness itself arises as a dialogical process with other human beings. So this gets us down to what Michael Polanyi refers to as personal knowledge. And I think we have to take that very seriously. So Bill's robots are going to have something like this if they're going to be as capable as we are. And what is it like to be a human? They're going to have to be very much like human beings in body form, body size, and by the way, also existential angst, a sense of the quest for meaning.
Yeah, quest for meaning is it's hard to conceive, how that arises mechanistically, but it is a very central part of our mental, emotional, and spiritual lives. I want to just go back briefly to Janice's question. Janice, what your question rang, the bell it rang for me in my mind is Plato's notion of ideals, and I was in a philosophy department at Duke listening to a seminar, and the questioner, I've learned that philosophers do this. They write their questions out and they read questions to the speaker after they write these little essays, and she said, imagine there is visitors from a different galaxy, a different star, and they came to us. And it was a planet, they came from a planet in which the dominant form of life was lobsters. And they had come up through an entirely different evolutionary scheme, but this lobster-like entity is here. And tell me, in order to get from that galaxy to ours, do you think they would had to have had the same physics and mathematics that we have in order to be able to move different places, large distances? And this aroused a lot of discussion, and it gets, I think, down to the question of do we believe that humans invented mathematics and invented physics, or do we think they discovered mathematics and discovered physics? And if it's the latter, and I tend to think it's the latter, and I've been accused of being a Platonist. I don't know what all that involves. I hope there's a good party in there somewhere. But I think that the laws of physics and relations of mathematics pre-existed in this universe before humans ever were on the scene, or any other animal was ever on the scene. So I think we discovered those things, which means I think there's some reality out there that is independent of the human mind, that can be grasped to some extent of the human mind, and that doesn't have I don't know, we could argue whether laws of physics are embodied in some larger planetary embodiment thing, but I think those things are real. I don't think it's crazy to think that way. But that didn't sound like what you were asking. It sounded like you were asking specifically, can we know things, or can things be known without a brain or a nervous system? And I know nothing about Aristotle on that, so maybe you could teach us.
Well, I think the implication of that question from Aristotle is that maybe there isn't a kind of one-for-one correlation, right, between mental functioning and some kind of physical substrate. And if that's the case, then yeah, I mean, I think the direction in which you guys took that question was actually theological, right? I mean, Plato is actually quite theological in his understanding of things. Yeah. And I think in many ways, I mean, this is getting at a further question, which is, does the brain reveal anything about God, right? I mean, does it reveal something about our belief in God? Does it, say something about God himself, if people believe, right, that God created, right, the world, and that the brain is somehow created by him? I mean, we know that in the decision-making research, I mean, I think you've, right, as you look at this, there are biases, cognitive errors, right, that are intrinsic to reasoning. And, I mean, from a philosophical standpoint, one might say this looks like a kind of small problem of evil, right? I mean, if we do think that there is this greater thing out there, as you're saying, Professor Newsome.
Yeah. I resonate to a lot of what you said there. I think that there are, spiritual dimensions to this kind of discussion. Just to put my cards on the table for all the participants here, Bill and I, another thing we share is we both come from a Christian tradition. I'm actually the son and grandson of Southern Baptist preachers, believe it or not. I'm actually a member of the Episcopal Church now, but Christian faith is a very important part of my life, and it infuses everything that I think about and the way I think about the how I think. In fact, as a college student, one of the things that attracted me into neurobiology is that I had the deep sense that somehow we live in a unitary world, and somehow the world I experience in a laboratory must be come from the same organ up here as the world that I experience in a church pew or during a moving religious experience. And the only thing worth doing with my life was studying what that is up there that mediates all of these realities. I thought that was an incredibly cool thing. It was part of my motivation for getting into neurobiology. So I don't resist that notion at all. I think there are a lot of fundamental questions that we all have to ask ourselves in the end that are religious, theological questions. And I want to say I don't detach those from doing science. It's all a part of me. And, but I do detach it. I mean, the experiments I do in the lab are not driven by theological issues, but or religious ethical issues. But I hope that the more human aspect of the lab is driven by those things. The way I treat students. I hope that's informed. If that's not informed, then it's not worth much, is it?
Yeah, so Bill, that makes you exhibit A of your primary point that meaning is driving human existence. Your whole career is fundamentally lodged in that core question. And that's very interesting because Einstein is famous for saying something to the effect of the most incomprehensible thing about the world is that it is comprehensible at some level. And though he may have meant mathematically comprehensible, I think we can extend that into some sense of the possibility of penetrating its deep moral and spiritual meaning. I think Eugene Weiner, is that the guy who said something to the effect of how it didn't have to be that the human brain could understand all these mathematical principles that you referenced, but it's amazingly made that way, that it seems that the world it can be comprehended in terms that the human mind can penetrate at least very deeply into. And that's very interesting because it's much more than mathematics. To my understanding, and referencing back to the human body form is such that we have a kind of capacity to interact with one another that we can truly penetrate into each other's minds. It's this idea called theory of mind, but it's only possible, I think most people recognize this, because we are upright creatures. We have a furless canvas of communication, the roughly 30 muscles of our face, and we can follow each other's thoughts very deeply, which means we can engage, and we have a great drive to understand and engage with one another. And in the process, we collectively, synergistically, ascend into a deeper and deeper understanding of the material world, and I think probably the spiritual world also. And in the process of understanding the moral and spiritual dimensions of existence, that may be drawing us very much to the heart of the cosmos, because as it says in the letter of St. John, God is love. And if God is love, then human life is such that it is ordered to understand love, and most deeply, of course, through the testimony and the self-evident revelation of love through the person of Jesus. And here we get to the very, very crux of the whole matter. It was written, it was explored in a book by, you referenced John Templeton Foundation. Well, I knew John Templeton personally, and he was very much rooted in the conviction that the world was such that you could engage it in such a way that you would understand and increasingly penetrate into its depths, into the mysterious foundations of existence. He even wrote a book called The God Who Would Be Known. So I think there's something amazing going on in human beings. that we aren't taking quite seriously enough. There seems to me to be some kind of a trajectory across phylogeny where the cosmos is increasingly becoming conscious of itself.
Thank you. That's really beautiful. I mean, I think at this point we do want to move into the Q&A, but as moderator, I'm going to, if you guys don't mind, I have a follow-up question since we're talking among friends who sort of inhabit the Judeo-Christian tradition. So if we are brain chauvinists, right? So I'm really actually interested in what Professor Newsome was saying earlier about, right? If you take your brain, right, and place it in another body, you go with your brain, right? And so I'm interested.
Not everyone would agree with that, Janice.
Right, I know that. Yeah, I don't. Yeah, I myself am worried about that. So, so sorry, sure. but from the Christian perspective, right? I mean, Christians believe in the resurrection of the body, and how exactly would this work, right? Sort of within this hypothetical.
Easy questions.
It's easy.
I think you need to add that to Chalmers as the really hard question.
Okay.
I do not have a good physical theory of resurrection, Janice. I don't. Most of the time when I think about the possibility of life beyond this one, I can hardly even think about it. It's just too strange. But you know, back in when the millennium turned in 2000, people were, you know, speculating about what the next century would bring, or the next 1,000 years of scientists. They had humanists and musicians and this and that and the other. But I remember, you know, Steven Pinker talking about artificial intelligence and the increasing possibility that we might be able to, in some sense, at some point in the future, in the next millennium, download our consciousness into a different device. And you know, this is not. I mean, I've seen Freeman Dyson has some of the same speculations in his writings. And there, you know, that is a continuation. It's a presumed continuation of some form of personal consciousness in another form that can depart this body. So I don't think that this is a crazy thing to think about, but in terms of molecules, you know, because what happens when we die? I mean, we rot. That's what happens. Our bodies rot. And it gets eaten by worms, and those molecules then go into fish and get eaten by other humans. And that same molecule belongs to a different human, probably many different humans. So I don't have any physical theory of how that might come about. If I did, I'd probably be, if I had a good theory of resurrection, I'd probably be a more consistent and faithful Christian. But unfortunately, I have these doubts.
Okay, well, thank you. Yeah. So let me turn to, we have a Daniel Green. Can you guys see the questions, or should I read them to you?
They're in the Q&A.
Right.
Read them to us.
Sorry. Okay, I'll read it to you. Okay, so we have someone who says, I'm a machine learning PhD student at Princeton, working with Professor Jonathan Pillow at the Princeton Neurosciences Institute. Lots of papers try to explain the brain using machine learning algorithms as mechanisms, for instance, Bayesian brain hypotheses, dopamine-mediated reinforcement learning, etc. Do you think that this is a category error? Should machine learning algorithms be used as potential explanatory mechanisms? Or is this just a reincarnation of our tendency to assume the brain works like our most sophisticated technology?
So it's a great question. And Daniel, I don't know if I've met you before, but I certainly know Jonathan, and nice to have a colleague participating here this evening. You know, I think that people were trying to explain the brain according to the Reverend Bayes, and according to dopamine-mediated reinforcement learning long before AI really took off. The modern revolution in AI is only 10 years old, right? Because of the advance of massively fast computers and you know, the deep learning structures, the deep layered structures of the networks that it's possible to run now. But people have been talking about the Bayesian brain and about dopamine-mediated reinforcement learning. So I don't really see that as a result of machine learning. I do see it as a result of trying to find principles. I mean, Bayes lived in the 1600s, right? And trying to find principles about how you extract sound knowledge, probabilistic knowledge about the world the best you can, given the evidence at hand and your experience as an organism. And so I don't think that's a category error. I do think that there's a tendency to explain the brain in terms of our favorite technology of the contemporary moment. You know, we've been through telephone switchboards, we've been through abacuses, we've been through simple digital computers, and now we're in deep learning networks. So I do think there's a tendency to do that. But as a neuroscientist, I think it's really interesting whether the current machine learning algorithms and the current machine learning abilities that are amazing and exceed human abilities in certain specialized niches, are those algorithms and are those internal structures that get built as the artificially intelligent entity learns how to solve a problem, are they similar to the ways that the human brain is doing that, or are they different? And there's a lot of discussion, as many of you know, in academia right now, and it's not just an academic question. It has real consequences, like who do we hire on our faculty? Do we want people who can facilitate this interaction between neuroscience, what I call NI, natural intelligence, and AI, artificial intelligence? And are they going to converge at some point in the future on a certain set of principles underlying intelligence? Or are they just going to be like ships passing in the night, just parallel universes with really little productive interaction between them? And I think that's an open question. There are certainly signs out there of productive interaction, and I hope that there's productive interaction. Certainly neuroscience is using the tools of machine learning, as you know, being in Jonathan's lab, much better than I do. But, you know, machine learning, vision, expert vision, artificial vision uses neuroscience, right? Their whole front end isn't learned. They build in the stacked filters, orientation selective, spatial filters. They just build that in because they know that's how human retinas work. And they know that's how biological mechanisms work. And they save themselves a lot of trouble just by baking that in at the front end of their learning network. So I think there's signs of a productive interaction in both directions, and I'm optimistic about that. And we do have to watch out for these category errors, but I don't automatically assume that reinforcement learning and Bayes are kind of, you know, AI-inspired artifices. A long-winded answer. I warned Janice. I said, you know, give me the throat cutting sign. Brevity is not my favorite.
That's right? Wonderful. Thank you. Yeah. Does Professor Hurlbut want to add to that, or?
Well, I'm not at all even well informed on these matters, but I have thought about them and talked with people about them, and I think there may be something going on here that is kind of it's a kind of what's been called by Richard Lewontin a process of backwards etymology. So first we use terms of familiarity to our understanding, and then we reverse the order. You know, we start to understand machines sort of partly in terms of the human brain, and then we reverse the order and we use it to understand ourselves. And I think that's a mistake. Artificial intelligence may in some way be mind-like, but that doesn't mean the human mind is computer-like. And I think that from what I understand about this, and admittedly I don't know very much, but I have talked with Terry Winograd, who was prominent computer scientist at Stanford, and he said 25 years ago, he said that human mind is infinitely more complicated than mathematical logic would allow. And at the time, he warned that the paradigm of computer thinking, comparing it to the mind, he said he said they are seekers after the glitter of intelligence, are misguided in trying to cast it in the base metal of computing. So it was true that the computer could outsmart the best chess player. Right? So we got that. And that was raw computation, as I understand it, just crunching it down much farther than a human mind could do. But it was still just rational computation. And then AI, if I understand it correctly, uses another kind of brute force, and that is by vast pattern recognition. And you know, the victory over the best Go player, if you've ever seen the statistics on it, it's really shocking. It's like the computer used something like 100 times as much energy and simulated something like 30,000 games to get where it got. But it did so by recognizing patterns, not by doing what we would normally think of as mental operations of a human mind. So at least at this point, I don't think computers are that much like human minds. I don't think computers think, and I don't think the human mind is just pure computation. And maybe that's about all I should say, since I probably already said things that aren't proper. But
I just hope the two of you don't get into trouble with your colleagues at Stanford. So
we probably will.
So we have
it wouldn't be the first time.
Right. Okay, well, you guys are still there. So we have a question from psychology professor Timothy Riley, who in fact used to be a colleague of yours at Stanford. He's now with me at Ave Maria University. So Dr. Riley asks, how do you think the extended development of human brains compared to other species might play into the development of human consciousness? Is there any evidence from developmental neuroscience that might provide insight into this?
Yeah, I am not going to be very informative on that question. Bill, do you have any? I mean, this is the neoteny problem, right? That's the fact that it takes human nervous system so long to develop. And I mean, I think that extended development is there for a purpose. But my thinking about it is very simplistic, and it goes back to this little girl I live with, and thinking about her at age 3 doing all of this sophisticated mental stuff that's just astounding. And to my knowledge, no other species comes close to developing these lifelong projecting narratives way back in time and way forward. And there must be something about our experience and something about that slow development in these highly social and fluid environments that's critical there. But I really don't have anything professionally qualified to say about this. I'm just grasping at straws here. And Timothy, I'd be much more interested in hearing what you think about that actually than what I think about that, if this medium permitted it. So if you have a good paper for me to read, drop it in the chat line or send it to me by email. I'd be happy to think about it. Bill, do you have any thoughts about this long developmental time that we humans go through?
Well, I'd like Timothy to send me that paper too, because I'm very interested in this. I will say this, there's been an effort to find some difference in the human neurologic substrate to see if there were special cells or special arrangements. And there do seem to be trajectories in the hominin phylogeny that do spell some differences. There's greater density of neuronal connections in the prefrontal cortex and so forth in our close relatives in the great apes and so forth. There are certain cells, von Economo cells, they're called, that seem to have some special functions in social creatures. But if I understand it correctly, there is nothing in the human substrate that is definitively associated with the ascent of consciousness. So that puts it back to what Timothy suggested. There might be a developmental process, an unfolding of awareness that takes place. And there I would say that the altricial nature, the slow development of a human being, I mean, we, compared to even chimps, we are very slow to reach maturity. And in the process, there's this very profound interaction between the child and the parent, most specifically early on, the baby. There seems to be some matter of intersubjectivity from very early. University of Washington psychologist Andy Meltzoff believes that human beings even within a few hours of birth can imitate the facial expressions of the person they're looking at, most specifically the mother. and that therefore they can feel internally the states of emotion and so forth, at least at some point early in the development, that the mother is feeling. So there is a very deep interpersonal nature to this early development, and it patterns in what I referred to earlier, the dialogical development of consciousness.
Thank you. So one of the topics that we did not get to discuss this evening was free will. So I'd like to come to this question from an anonymous attendee. So this person asks, if mental processes do not follow deterministically from the physical realities of the brain, what ultimately determines them? Oh, I think you're muted, Professor Newsome.
Well,
I muted myself because I had to cough. Go ahead, Bill.
Oh, sorry.
Do you?
Well, let me set Bill up here because he has a slide that's really great. It says something to the effect of, "I'm not a fatalist, but even if I were, what could I do about it?"
Yep. Yeah. So there are different conceptions of free will, right? And I'm trying to think of a way to say this pithily because I have a whole lecture on this that I do in our class. And if my freedom, what one means is that my behavior is uncaused, okay, there are no causes for my behavior in order to be free, then I don't believe in free will, okay? By the way, there's a long biblical tradition of arguments about this, right? Predestination versus freedom, but that's neither here nor there for this discussion. How I define free will is really self-determination. Okay, it's not determination from the outside. I'm not being coerced. If somebody puts a gun at my head and says, do this or else, then a lot of my autonomy is taken away. There are a lot of freedom I don't have just because of the structure of my body. I'll never be able to dunk a basketball like LeBron James. I don't have that freedom, right? And my brain puts limits on my freedom. But what freedom is to me is that my actions in the world are responsible in some part, and I'm going to leave that some part ambiguous. We can all take bets on what the percentage is, but to some extent, my actions are due to the things that I think make me most fully, uniquely, and authentically myself. So my memories, my aspirations, my goals, my beliefs, my values, and if my behavior is caused by those things, then that is a meaningful kind of self-autonomy. Now, there is a core of hardcore reductionism that ascribes all those things, beliefs, values, morals, memories, that they're folk concepts, folk psychology, right? And when we really understand the brain, we are going to be able to describe all of those things and say exactly what they are in terms of patterns of neurons, and we can leave that folk psychology behind. Those labels are conveniences, but they're not explanatory. They're not causal. You know, all the causation is down at the level of synapses and things like that. And if one ascribes to that, you get into this endless loop all the way back to quantum mechanics, because no geneticist is going to allow you to sit comfortably at the level of synapses and learning mechanisms and neurons. They're going to take this thing down to genes, and before you know it, you're sliding all the way into physics. And I don't think that physics is wrong about the world at all. I just think it's impoverished. So, you know, if we could write a Schrodinger wave equation that predicted the motion of all the atoms in your room right now, where you're sitting on Zoom, probabilistically for the next 20 minutes, you know, that's the best physics has to offer. It's a probabilistic description, predictions about the future, and that's an ideal. But that Schrodinger wave equation wouldn't have a clue about people, wouldn't have a clue about intellectual interaction, it wouldn't have a clue about hunger, it wouldn't have a clue about learning. It just is a wave equation predicting the motions of atoms. And so I resist that kind of reductionism, what I'd call eliminative reductionism. And when I think about the nervous system, I'm a reductionist in my techniques. I believe that mental processes are physically mediated, but I think that a belief is a high order configuration of the nervous system, and that high order configuration and the relationships it has with the rest of the nervous system is causal. Okay, it actually has causes, it has power. And I'm the first person to admit that much of my behavior comes from things that I'm not conscious of, things that are not consistent with my values. I believe with Freud to some extent, and Stan Dehane with a more modern scientific concept, that we are a bundle of biases and a bundle of heuristics, and a big part of maturing as human beings and becoming more free across our lifetime is identifying what those biases are. And I know this stuff because I grew up in the South in the 1950s and 60s, and I grew up in segregated, my little town of 10,000 people was totally segregated. There were black schools and white schools and bathrooms, the whole swimming pools, the whole bit. And a large part of my maturation was becoming aware of the extent to which my culture had, set up so many biases that I have had to work a lifetime to continue overcoming, and that's not something that happens in an instant, in a moment of conversion. You have to keep working at it. But I think I'm more free, and that shows another important thing, Joy, that I believe, Janice, is that consciousness is causal, right? Because until you become conscious of your biases, you have no hope of eliminating them, no hope at all. If somebody shows me a bunch of data that as a professor, I've been systematically grading different classes of students differentially, whether it's by gender or by accent or appearance or whatever, it's only when somebody shows me those data, I say, I can't deny that, that then I have an opportunity to change. So I think consciousness is causal, and I think that these high level states of the nervous system are causal, and I think that is the key to my own conception of freedom. It's not that there are no causes. There are causes. The question is what counts as a cause, and can you use these higher level states of organization as causal reasoning about behavior? And I think you should, not just can, you should.
Excellent, thank you. Quite eloquently stated. So we have a lot of very excellent questions. I'm afraid that many people are going to be very angry with me, but I think that if we have time for just one more question, and then perhaps I can ask you to sort of wrap up with some very brief closing comments from each of you, if you don't mind. So the last question is from Dylan Stull, who is one of your Stanford Medical students.
We both know Dylan quite well.
Okay, good. So this person writes, I would like to be the first Stanford medical student to hear an answer to your own dreaded question. When Penfield, I can see your students know you well too. When Penfield stimulated the visual cortex, why do you think it is that the research subject had the experience of seeing something? And when stimulating the auditory cortex, why the experience of hearing something? In Nagel's framework, how do the third person processes of the brain connect up with the first person experiences we have?
Yeah, the reason I dreaded someone asking me that is because I don't have an answer to it. I could do a neuroscientific dance around it, because, I primed you to see it like me by saying, all you're doing is stimulating neurons. It's just electricity activating neurons. Why is the subjective experience so different? But it's not just electricity activating neurons. Those neurons are connected to different parts of the brain. They have a different web of connections. Those connections have been shaped by different experiences over the course of your lifetime. And I could do a little dance like that, a little just so story that says, it has to be something about that context in which those neurons are activated that include their communication partners, that accounts for the separate subjective sensations. But that dance still would not say why there should be a subjective sensation at all associated with that. Why is a subjective sensation necessary, or is it necessary for the functioning of the brain? This is in philosophy circles. These are the what do you call them? The unconscious lumbering. I'm blanking on the word. I'm having a senior moment. Zombies. These are the zombies that run around, acting the way that we act all the time, but don't have internal feelings. And it's quite acceptable in some philosophy classes, at least, to talk about zombies and lobsters from another galaxy. And they can be very enlightening, but I don't know the answer why there should be a subjective experience. It just is. It just seems a brute fact that activity of certain parts of the nervous system have subjective experience associated with them. Not all of the nervous system, by the way. Neurosurgeons have this concept of silent cortex where you can electrically stimulate and the human subject feels nothing. Versus eloquent, silent versus eloquent cortex. It's really interesting. I don't know. That's a long way to say I don't know.
You're very good at that.
Yes, I know. So I've been told. I have a funny story about that, actually. The funny story is I was invited by a justice of the California Supreme Court, who I know, he was a former Stanford colleague, to come do one of their summer Friday afternoon colloquia. They like to have interesting speakers in, and justices and lawyers they like to think about the human brain. Where does all this behavior we see in the courtroom come from? And one of the justices asked me a question, and I gave some characteristically Bill Long answer to it. And I could see her eyes drifting off. I could see them glazing over after about, I don't know, 90 seconds or something. And I stopped at some point. I said, "Am I answering your question?" And she said, "I believe you said yes." Oh, I tucked my tail between my legs and got back home to Stanford and resolved to learn to speak more pithily.
Oh, we've really enjoyed this. Thank you very much. And may I ask if there are closing remarks that either or both of you would like to offer?
The only closing remark I have is that probably, at least in the circles that I move in, we don't talk about these things enough. Mm-hmm. Bill and I try to create a space for this kind of discussion in our course. And Bill's, I think, genetically prone to these kinds of discussions. You can't stay in his presence for 5 or 10 minutes without getting into a discussion like this. Maybe that's my own weakness. But I think all of us should think about these things carefully and learn from each other. I certainly don't think, I certainly don't have it all sorted out. If I did, I'd be writing a book and being famous, but I don't have it sorted out. But I enjoy talking with serious people about these things.
So
Bill Hurlbut will end us in good style.
So let me conclude with a couple of comments about what Bill just said. I referencing back to your very, very difficult but significant question about the resurrection. I think I believe in the resurrection because of other things that I can explore and test in the world and examine for their truth qualities. In other words, even though it's a deep mystery and beyond a kind of empirical analysis, except for the datum of Christ's resurrection as testified by the disciples and apostles who were willing to die in the conviction it was true. But apart from that, I have a subjective sense that all the other things that Christ did and said were so deeply coherent in truth that I'm willing to accept something that is mysteriously beyond my sense of proof. But that is a subjective reality. But I also think that subjective realities are central to not just our sense of meaning, but our whole sense of balance and relationship with the world. John Muir is famous for saying that, among other things, among many wonderful other things, John Muir said, the power of imagination makes us infinite. And I think that it's our capacity to imagine alternative worlds that leads us as explorers in the world and beyond the world to make meaning of our lives. And here I would only say that in reference to both the resurrection and to the whole arena of the things we've been talking about, we are so far from having a kind of knowledge of the brain that is dismissive of those things which our traditions have held deep and true, that we are being besieged in a certain sense by a modern error, and I think it actually amounts to a modern superstition of a kind of reductive and analytic, materialistic view of existence. If we back away from all of that for a moment, let our imaginations at least consider alternative realities or complementary realities, we can enter what John Templeton called the humble approach, that we can give some credence to the depths of mystery that we have not yet penetrated. The great naturalist John Burroughs said, after science has done its best, the mystery is as great as ever. And that's a really beautiful saying, I think. And it's especially important saying right now, because Bill and I are very involved in this project called The Boundaries of Humanity, Humans, Animals, and Machines. And the central goal of that is to start to contend with the biotechnological possibilities that are emerging. Because if we don't, we might have serious errors in derailing and writing ourselves right out of our own human story. And the point being that it's really important for us to both sustain the rigorous ascent of knowledge and to also remain humble about how little we know and how much there is to learn. The great physicist Niels Bohr said, we're both spectators and actors in the great drama of existence. And since we are actors, we better act only with humility and go forward in cautiously and well considered. And that means not throwing anything out. The first principle of intelligent tinkering is never throw away any of the parts. And I would say those parts include not just the material mechanisms, but the long-standing philosophical and theological traditions from which we can learn a great deal. And from my standpoint as a Christian, I keep in mind that quote from the Psalms, which is also, by the way, the motto of Columbia University. And it says, it's referencing God and through Christ. And the quote is, he is the light in which we see the light. And to me, my faith acts to orient and align my thinking, hopefully in a humble way, but in a way that keeps me connected with what I consider to be the deepest questions and the most compelling statements about reality.
Those are beautiful closing remarks from both of our eminent speakers. Thank you so much for that. And I'm sure our audience very much appreciates all of this and joins me in thanking both of our speakers for the evening. We hope there are many more conversations like this. As Professor Newsome was saying, we need more. So I'll now turn things back to Dr. Dan Shealy. Thanks very much.
Oh, wow. Well, thank you, Professor Hurlbut. Thank you, Professor Newsome. And thank you, Dr. Chi, for facilitating that deep, challenging conversation, which I suspect I don't speak only for myself. We'll keep our minds working long after tonight's program has ended. If you found this program enriching and worth sustaining like I did, please consider supporting our project, which you can learn more about at the website in our chat box, collegiuminstitute.org/Magi Project. Please also find there in due course information about our upcoming events, including a December 2nd lecture by Jonathan Lunine, Professor of Physics at Cornell University, on faith and the Big Bang Cosmos of Georges Lemaitre. And that event is hosted by the Morningside Institute at Columbia University, which is sponsored by the Collegium Institute's Lemaitre Award, which is one of 2 awards granted through an annual Collegium application cycle and contest to advance the work of the Magi Project in other university communities and publics. Then the Collegium Institute's own Spring Magi Project Forum will take place on April 8th, featuring Professor Marcelo Gleiser, Professor of Physics and Astronomy at Dartmouth College, on nothing less than mystery, beauty, and the meaning of existence. So if you ever wonder about those subjects, tune in on April 8th. And finally, the Collegium Institute's very next upcoming special event, related not to the Magi Project, but to one of our other core programming areas, the Genealogies and Modernity Project, will take place on Wednesday, December 9th, entitled Deep in History on Christian Genealogical Thinking, featuring Professors Thomas Pfau, Brenna Moore, Maria Cecilia Ulrichsen, and Cyril O'Regan. So we would be delighted to have you with us for any of these events or the many others that we'll host in the coming months on Catholic thought and on the lowercase c Catholic or universal questions of life. So thank you again to our brilliant speakers, and thank you all for your presence with us. Have a good night, and peace be with you all.